Nature is full of incredible animals, all of which have adapted to their environments over time and move or behave in interesting ways. By replicating these animals with technology, we can achieve great things too, or just have some really cool robotic pets. Here are some of the most amazing robotic animals you gotta see. Spot, robot dog. Let's start with perhaps the most famous robotic animal on this list, Spot the robotic dog. Created by Boston Dynamics and first launched in 2019, this mechanical version of man's best friend is a versatile helper bot that can be tailored to suit many different uses. Its sturdy design enables it to navigate rough terrain while avoiding obstacles. Plus, it offers different levels of navigation, remote control, and autonomy. Spot can be personalized by integrating sensors, software, and other payloads. In 2020, one was used to promote safe distancing in parks in Singapore. Other uses so far include monitoring construction sites and performing remote inspections for oil and gas, power installations, and public safety purposes. Cheetah robot. Boston Dynamics and students at the Massachusetts Institute of Technology have also developed robotic cheetahs. Best known for their speed, the robotic versions of this rapid mammal can reach speeds upwards of 28 miles per hour, which is faster than former Olympic sprinter Usain Bolt's quickest 20-meter split. The model developed by MIT students doesn't just run fast though, it can jump over hurdles autonomously as well. In fact, it was the first four-legged robot ever to achieve this feat. Bionic kangaroo. Okay, so since we are talking about jumping, what better animal is there to replicate this than a kangaroo? That's what the German company Festo decided to do back in 2014. Its bionic kangaroo mimics the marsupial and even has the ability to recuperate and store the energy expended during a jump within its Achilles tendon, which in the bionic version is replaced by an elastic rubber band. The artificial tendon is connected to the back of the foot, running parallel to a pneumatic cylinder located at the knee joint. This setup initiates the jumping action. When landing, the synthetic tendon acts as a cushion, absorbing and storing the kinetic energy, just like a real kangaroo. It then releases this stored energy for the subsequent jump, employing the same technique as its natural counterpart. Amazing, right? Robird. But why jump when you can fly? Robird possesses flapping wings that enable it to take flight and emulate the flight patterns of a falcon. It's capable of sustained flight for intense periods of up to 5 minutes, and similar to its natural counterpart, it can achieve speeds of up to 27 miles per hour. Robird was initially created by the Netherlands-based company Clear Flight Solutions, also known as the Drone Bird Company. It has since been adopted at airports around the world, such as in Canada, where it mimics a peregrine falcon and gracefully glides in close proximity to the runways, discouraging other birds from disrupting air traffic. Bionic flying fox. Also taken to the air is this robotic flying fox created by Festo. Its developers extensively studied the natural flying fox to replicate its unique flying abilities. By combining onboard electronics with an external motion tracking system, this lightweight mechanical version can operate semi-autonomously within a specified airspace. The artificial flying fox has a wingspan of 228 centimeters and a body length of 87 centimeters, while weighing a mere 580 grams. Just like its biological inspiration, its wings are divided into primary and secondary sections, covered with an elastic membrane that extends from the wings to the feet. All articulation points are aligned on a single plane, allowing the bionic flying fox to independently control and fold its wings together. Batbot. A similar yet much more lightweight design, considered to be the first robot to look and fly like a bat, is Batbot. Created by 3 roboticists at Caltech University, it was a remarkable engineering achievement since, arguably, bats have the most sophisticated powered flight mechanism among animals. Despite weighing just 93 grams, roughly the equivalent of 2 golf balls, Batbot exhibits a silicone membrane stretched over a carbon fiber skeleton. The model is equipped with an onboard computer, sensors, and 5 micro-sized motors along its backbone, allowing it to autonomously engage in flapping flight. Bionic Wheelbot. If you're not a fan of spiders, try to remember that this next entry is just a robot. Inspired by the Moroccan flick-flack spider's unique locomotion, Festo's Bionic Wheelbot imitates both walking and aerial movements. Incredibly, it can perform somersaults and rolling actions on the ground, allowing it to propel itself into the air. When in rolling mode, the Bionic Wheelbot is twice as fast as when walking. The knee joints and body house a total of 15 small motors that control its movements. Additionally, there are 14 automatic locking worm gear units that enable the Wheelbot to utilize energy solely for leg movement, without expending energy to maintain its body upright while stationary. As for its usefulness as a robot, well, maybe it can help you to overcome your arachnophobia. Bionic Ants. Sticking with the creepy crawlies for the moment, Festo has also come up with bionic ants. Ants are diligent creatures that live in extensive colonies with well-defined social structures. Their ability to work together as a team empowers them to accomplish tasks beyond the capacity of an individual. By drawing inspiration not only from their intricate anatomical features, but also their cooperative behavior, we can also achieve more as humans. The bionic ants use sophisticated control algorithms to coordinate their actions and movements, bringing the cooperative nature of real ants into the realm of technology for the very first time. Robotic cockroaches. You may be wondering why anyone would want to invent a robotic insect, but according to researchers in Asia and America, cyborg cockroaches could one day save your life. That's because they're mighty tough and able to reach disaster-stricken areas that humans can't. Scientists have successfully demonstrated the capability of attaching backpacks containing solar cells and electronic components onto cockroaches, enabling their motion to be controlled remotely. The roaches are still able to move unrestricted, but the integrated solar cell transmits directional signals to the sensory organs located on the bug's hindquarters. This allows them to be directed into disaster zones, such as the rubble of an earthquake, locating any survivors without putting human lives at further risk. Just imagine, seeing a cockroach one day may be a relief instead of horror. Crabster CR200. In Korea, a multi-legged walking and flying subsea robot named the Crabster CR200 has been made with the support of the government. The Crabster offers a viable alternative to propeller-based remotely operated vehicles, or ROVs, and autonomous underwater vehicles, AUVs, that face challenges when dealing with powerful tidal currents in shallow waters. In contrast to ROVs and AUVs, the Crabster features a unique design which can be deployed at depths of around 200 meters, or 650 feet. Once submerged, it uses its 6 legs with 30 joints to traverse the sea floor. This leggy movement provides enhanced stability while minimizing debris disturbance. Just like actual crabs and lobsters, the robot features manipulators on its front legs too, allowing it to grasp and store objects in a frontal compartment. Additionally, the researchers have engineered the robot shell to adjust its posture, deflecting strong currents. Eolume. Offering an alternative method of subsea inspection is Eolume. Autonomous robot arms with a slender and flexible body. These robot eels can autonomously navigate long distances and perform inspection and maintenance tasks in tight and inaccessible underwater spaces. Eolume has already proven itself exceptionally well suited for missions on offshore wind farms, fish farms, oil and gas production facilities, and pipelines. It can be equipped with various sensors to carry out environmental surveys, including detecting gas leakages, oil and water, salinity, temperature, and sound levels. Designed to operate permanently underwater, Eolumes can also be deployed 24/7 regardless of weather conditions. Simply put, they facilitate greener, safer, and more cost-effective subsea operations. Octopus Gripper. Taking inspiration from another sea creature is Festo's octopus gripper. Octopus are captivating creatures that possess a unique physical composition. They lack a skeleton and consist mostly of soft muscle tissue. These exceptional characteristics grant them remarkable flexibility and maneuverability. As such, an octopus can navigate through water with agility in various directions and skillfully grasp a diverse array of objects with its tentacles. The bionic octopus gripper is made from a flexible silicone structure that can be controlled pneumatically. By applying compressed air, the tentacle bends inward, allowing it to envelop objects with a precise and gentle grip. Similar to a real octopus, the silicone tentacle features 2 rows of suction cups on its interior. While the smaller suction cups at the gripper's tip work passively, the larger suction cups can create a vacuum that securely adheres to objects. Thus, the versatile design can effectively grasp and hold objects of various sizes and shapes. Aqua Penguin. Of course, automation company Festo have also dipped their happy feet into the water with their Aqua Penguins. Just like the real deal, Aqua Penguins possess an energy-efficient, streamlined form. Using their wing drives, they demonstrate exceptional maneuverability, effortlessly navigating through narrow spaces, executing precise turns, and even exhibiting the ability to swim backwards, an ability which is not boasted by their natural counterparts. These artificial penguins can independently orient themselves and display diverse and adaptable behavioral patterns when operating as a group. But mainly, they're incredibly cute. Biohybrid Stingray. At Harvard's Disease Biophysics group, some big brains got together to create a light-guided bioengineered stingray, which could pave the way for the development of artificial organs as well as living biological robots. Remarkably, this miniature swimming machine is a combination of robotics and living tissue since it's powered by rat muscle cells. While earlier biobot projects have used biological actuators for movement, the biohybrid Stingray takes a significant step forward by featuring an intricate propulsion mechanism that's activated by light. This system enables the RoboRay to maneuver around obstacles with expert precision. Plurobot. In Switzerland, researchers at the Technology Institute (EPFL) developed a robot called Plurobot, which is inspired by the movements of salamanders. Through the use of 3-dimensional X-ray videos, they were able to capture the locomotion of Pleurodelis waltzi salamanders as they walked on land, underwater, and swam. By tracking up to 64 points on the animal skeleton, they meticulously recorded the intricate bone movements and postures for its various gaits, determining the right configurations to achieve an accurate reproduction of the salamander's motions. The main goal of the project was to further understand the way that the nervous system coordinates movements in vertebrates. Bionicopter. Inspired by the flight of the dragonfly, Festo developed the Bionicopter in 2013, successfully replicating the creature's intricate flight capabilities. This ultralight flying device exhibits the ability to maneuver in any direction, maintain a stable hover, and gracefully glide through the air without the need for wing flapping. Viewed as a groundbreaking achievement, its success means that for the first time, a single model can surpass the combined flying capabilities of helicopters, motorized aircraft, and gliders, mastering a whole array of flight states. E-motion butterflies. These e-motion butterflies are sure to make you happy. To copy their natural role models as close as possible, the e-motion butterflies use advanced onboard electronics. This enables them to exert precise control over each individual wing, allowing for swift and agile movements. With their wings slightly overlapping, the artificial butterflies create an air gap between them as they flap, resulting in unique aerodynamics that further enhance their flight capabilities. Tombot Robotic Emotional Support Animals. Up next, say hello to Jenny. This adorable pup was created by Tombot as the world's most realistic robotic emotional support animal. Jenny's purpose is to provide companionship and emotional support to individuals who may benefit from the presence of a pet but are unable to have one due to various reasons. such as allergies, living situations, or personal circumstances. Jenny can offer comfort, reduce stress, and provide a sense of companionship and emotional well-being. She's equipped with advanced animatronics and artificial intelligence technology to simulate lifelike behaviors and interactions. She responds to touch and sound, offering comforting gestures such as wagging her tail, nuzzling, and making gentle sounds. Jenny's expressive eyes and facial features contribute to her realistic appearance, creating a sense of emotional connection for those who interact with her. If you could own any robotic animal, which animal would you choose and why? Let us know in the comments. Leave a like if you want to see more, and subscribe to the channel so you don't miss out on future uploads. That's all for now, but we'll see you again soon. Bye!